equation is on the top is going to be what you actually make when you perform it. So we call it the actual yield. Okay, this is determined from the lab. Like you actually do it and you measure how much you made. Or on the AP test, it's going to be given in the problem. Because obviously you're not going to go do an experiment during the AP test. But generally that's where it's coming from, is it's coming from you performing the experiment. The bottom is known as the theoretical yield, which in a sense is the perfect score, right? How much you should be able to make if everything goes right, which is found through stoichiometry. Because when I do math, I don't spill things, I don't mismeasure things, I don't misweigh things, I don't make mistakes when I'm just working with the numbers. That's why there's a difference. There's also a difference because some reactions are just very temperamental, and it's hard to get them to bond fully. And so you may not be able to get as much as you thought. Okay? And then, of course, times it by 100 to make it a percentage. Okay? So if we wanted to find the percent yield for the equation we talked about last time, we first would need to know how much grams of acetylene we actually made. So in a lab setting, I would do the experiment, I'd gather the gas, and figure it out. It's hard to actually do that because gas is a hard thing to truly capture and weigh. So we're just going to say we did it and we got 1.5 grams of acetylene. Once again, this number is either going to be already in your problem or we're doing a lab and you're finding it. Okay? So if I want to know what the percent yield is, I would just take my actual, which is my 1.5, and compare it to how much I theoretically got, which we calculated on number 2. So if you want to draw an arrow from number 2, that's where we calculated the theoretical of 2 grams. I guess I don't think it was even 0.0. I think it was just 2, right? Okay. So once again, this came from number 2 up above of finding the theoretical. The 1.5 is what we got from the lab, times by 100, and we get a percent yield of 75%. Which tells us in our lab, in a sense, our grade of how good a job we did as scientists, right? We got a 75% yield of what we could have gotten. Questions on that equation? Okay, don't say anything out loud, but move your head, yes or no, in response to this question, but don't say it out loud, okay? Is it possible to get over 100% yield? Nod your head in how you think. Yes? No? Can you get over 100% yield? I guess if you want to say maybe, you can like go in a circle. Okay, I'm seeing lots of yeses. I'm seeing some maybes. Seeing people who aren't moving their head, who are maybe still thinking. Okay, Caleb, you're saying yes. Can you tell us why?
Because if you like mismeasured and added too much of everything, you would get more than you had predicted.
Oh, okay, so Caleb's saying, I said I was going to measure 5 grams, but let's say I mismeasured and actually started with 5.5 grams, but I thought it was 5 grams. That, in a sense, would give me over 100% yield. True statement. Have a smiley face for that. Now, does that mean I actually created more than what I started with? No. So that's why it's kind of a tricky thing. Like, you can mathematically get over 100%, but in actuality, you can't make more than 100%. But sometimes the math can deceive you. Another reason is for impurities. Is you can get over 100% if your sample's impure. One great example is if it still has, like, maybe it was a reaction in water, and then you need to dry it. If you don't dry it all the way, but you put it on the scale, it's going to show you a bigger number because of the water still there. But in terms of what it actually is, you don't really have that many grams of your substance. Some of it is water. So when I was in college, when I took organic chemistry, pretty much every lab we did was to synthesize a chemical, right? They'd tell us, like, all right, one day we made benzocaine, which is like a numbing agent, like, right? So at the end of it, we could like put it in our mouth like they do in the dentist. We didn't do that because they weren't very pure samples. But theoretically, that's what we were making. Our grade on every lab was determined by our percent yields. So it was dependent on, in a sense, how good a job you did at making it, but also the purity. So we'd also run it through a mass spectrometer to measure how pure our sample was. Because if you get a 98% yield, but your sample's only 50% pure, right? Like you're not selling a very good drug, right? Because you're like selling something that's really, it's not. So it's really like a combination of both of, right? You want a high percent yield, but also matching the purity. This is like such a big deal for pharmaceuticals because like this is their money, right? Like if pharmaceutical companies only getting a 10% yield, that's a lot of money that's being wasted, right? Like you put all this in and you're only getting this much out. But some reactions are really hard and they can be like 20-step processes and it can be very difficult to get a high percent yield, which is why some drugs cost a lot of money, is because it's really hard to make it and they're using all this to make it, but they only get this much out. But it's a really big thing, like this is something obviously like you were a production company, right, you'd be wanting to try to maximize this because that's going to save you money. So, questions on how to do it, but also like what it represents. Okay, let's try a problem similar to the ones we did last time here of converting units. Okay, so this problem says, according to the balanced equation above, how many grams of ClO2 are needed to react completely with a 0.020 liter of a 0.2 molar KMnO4 solution? Okay, so it's similar to before, but the units are different. So I always start with, what do I know, and what do I trying to find? On our map, where are we starting, and where are we going? If I raise a hand, can anyone tell me one of those two pieces for smiley face? What unit am I trying to find? What unit am I starting with? Zachary, tell me one of those.
Are we starting with liters and solution?
Perfect. So I'm starting down here. Have a smiley face, Zach. Can someone tell me where we're going, Alex?
We're trying to find grams.
Good. So we're trying to get, oh, my star was still there from last period. That's funny. So we're trying to get to grams of something new. So this is going to be 1, 2, 3-step process. Okay? All right, so let's start with liters of solution. So I'm going to take that and put that here. So you have 0.020 liters of KMnO4. Now, as always, you should have a unit, liters is my unit, and a label. What are you talking about? Oh, let me clarify something. I just need to fix this problem. So this problem brings in a concept we're going to learn on Wednesday. You don't really need to know it, but it does make it a little slight confusing because we're talking about KMnO4, but if you look at the balanced equation, is there KMnO4 in the balanced equation? No. No. So we're going to learn about on Wednesday these things called spectators. Because it's in solution, these things separate like salt does, right? And sometimes things separate and they just watch the reaction, but they don't actually do anything. And so we sometimes get rid of them in the balanced equation. And in this case, K is one of those things. So really what it's talking about is just MnO4. But all the problems on your homework, I cleared that up. I just forgot to change this one for that thing. But, okay, so we're looking at MnO4. Okay, step 1 is to change it from liters to moles of the same substance. So the pattern goes, whatever unit is here should go here. Now I'm going to switch colors because I'm changing units. And I want to change it into, what do we want to change it into? Good, mole of what? Good, the same thing, MnO4. All right, I'm going to keep going with my units and then come back for the numbers once my map is built. Okay, so next step, so I've traveled from here to here. So now I need to travel from moles to moles. So the bottom here should also be mole of MnO4. And what mole am I trying to change it into? ClO2, right? The thing I'm trying to find. So mole of ClO2. Now, as a reminder, the only time the label can be different is if you're using moles. So notice it's a different label, it's MnO4 and ClO2. That only works when you're comparing moles. If the unit is different, the label must be the same, because you can't compare it any other way. But moles, you can compare anything to moles, right? I can compare pancakes to dogs if I'm talking about moles. But if I'm using grams, it's like a weird connection to connect grams of dogs to grams of pancakes, okay? Okay, one more step here. I want to leave moles of ClO2 and go to grams of it. Once again, once the thing on top is the thing you're trying to find, then you don't need to keep doing any more steps. So now let's plug in our relationships. Each of the relationships are independent of the other things on the side, right? They are just their own thing that makes those two things equivalent. We're introducing this a little bit with my general chemistry students, and we talked about the idea of how if I have 12 inches over 1 foot, what does that equal? 1. Why does it equal 1, Brissa?
I didn't say that.
Oh, I heard it didn't say
Oh,
it. Solomon?
so
Why does it equal 1?
because they equal each other.
Yeah, they're the same thing. That's the same idea with every single one of these. We're doing really fancy times by ones, is all we're doing here. Okay, so what links moles to liters of a substance if it's a solution? Jack? The molarity, so this road, when we filled it on your map, says molarity. Note that has to be given, because molarity can change. It's not a set thing. In our case, the molarity is 0.2, okay? So 0.2 capital M is the same thing as saying 0.2 moles over 1 liter, because that's what molarity means. So I'm going to put 2 and 1. The mole-to-mole relationship, where does that come from? Balanced equation. So I look up there, there's 4 of these.
Yeah.
Oh, I'm crazy. Thank you. 0.2. Yeah, kind of am. Okay, and then gram to mole, what connects those two things? Good. Molar mass, right? Atomic mass. I'm going to add up Cl and 2 oxygens. I added it up, but I can't remember. 67.541. Yeah, that sounds right, Alex. So that was added by 1 chlorine, 2 oxygens, periodic table, add them up. There's your molar mass. Okay, questions on any of my setup? Okay, now once again, here's how I would type it in my calculator. I'd start with this, 0.02 times 0.2 times 3, divide 4 times 67.45. That's how I choose to type it in, is I just take it step by step, but I ignore anything that's a 1. You can type them in as fractions. Some people like to times the whole top, times the whole bottom, and then divide them. That also works. Just be cautious with your order of operations when you're doing the math. So, Ian. Oh, I think it is 4 or 5. And then I believe with sig figs we get an answer of 0.20 grams, which is weird because there's so many 2's in this problem. Questions on setup or answers? Once again, your final answer should always have a unit and a label. Don't just give me a number. It means nothing. Yeah, Ian.
Why is the last
Because so this right here, once again, is an equivalency. And so it's saying if I have 1 mole of this, that's how much it should equal. Does that make sense? Now, some people, like, theoretically, you could put a 3 because there's 3 in the equation, but then the mass would have to be triple.
Oh, so you just divide it by 3.
So it's like, you might as well just put the simplest ratio there is. So, yeah. Any other questions? Okay, try, I don't know what the number is, but the last one on your paper for a smiley face as a table. Ready, set, go.
Okay, I'm kind of lost.
Yeah, me too.
Do we start with 1 point? Yeah, we start with 1 point liters.
And then we go to moles, and we use that 22.4.
Should I put a small map next to each of these problems next year? Would that
Yeah.
be nice?
Yeah.
Like, so you don't have to, like, I mean, obviously you have this one, but then it's like right there.
Yeah.
Yeah. Okay.
So 1.0. And then I wrote 22.4, but how do we get it to cancel out?
Would you just flip it? Could you just put the 22
Just flip it. You just put the
at the
22.4 on the
bottom?
bottom.
Can you?
I don't know.
I feel like you can. Wait, but now that doesn't feel. That feels weird. I don't.
Yeah.
But how else would you do it?
I don't know.
I feel like you have to do it.
How did you get that point too? Oh, wait.
It's from they gave it to us.
Oh, oh, they gave us the molarity, right? I forgot how to find the mole.
Balance equation.
What? Oh, oh.
Oh wait.
Wait, what?
What do you?
I'm trying to do what we did here.
Oh no, because that is liters of solution. This is liters of gas.
Oh.
And so you're using this balance equation.
Oh, oh.
You're saying here.
Okay, okay. Oh, I see. Okay. That makes a lot more sense. Thank you, sis.
Of course. Where's
Wait, but that doesn't cancel it out. Hold on, right? So it'd be 1 mole to 1 mole.
So on my, and it's but so on the map where I'm starting,
Oh, so we're trying to
I'm starting
find.
down here at liters of solution. You're starting in liters of gas. So what connects that? It's not polarity. So look at your map. What connects liters of gas to Does that help?
I am so confused. Where'd you get the 2 out of 3? Oh,
The
that's
what?
the balance
That's the
equation.
balance equation.
That's what I thought too. But I like, oh, but like that's what I get. Like I'll change it, okay,
I think I got it wrong. Wait, what did you get?
I haven't finished.
I got 334. I think that's wrong. Because I times.
Well, we weren't sure what to do with the first one, so we put the 22.4 on the bottom. Because then your liters right now don't cancel out.
True, you're right.
So there's the only way to make the liter cancel out is to switch it. I don't know if that's right.
I got 3 points.
6.4. Yeah. That's what I got. I just don't know.
I see.
She'll explain it.
Okay. Raise your hand if you need like another minute. All right, 1 minute, 2 minutes. Dose. Okay, 2 more minutes, and then if you're done and I haven't checked your answer, raise your hand so you can get your smiley face. Good. Have a smiley face.
And then, so for this one, we just switch it? Is that, because right now, I wrote liters over mole. So we put the 22.4 liters on the bottom.
Yep, because the 22.4 should go wherever the liter goes.
Okay.
Just like if you had inches and
So it
feet.
doesn't, it
Oh,
doesn't
because that
matter.
can
Okay.
just flip.
The units can flip, so like molarity is the same thing. So like you could write this fraction as this.
Wait, I got 0.6.
So they're
The
the
number
same.
has to stay with the unit because that's what makes it true. Does that
Okay.
make
Yeah.
sense? Yeah, but you can flip them and it's still equivalent.
Where'd you get that?
That number, you calculate it.
You do the
Because we're not.
molar mass.
We're going to grams.
Oh.
So you need the molar mass, and so that's where you add up all these things.
Yeah.
That's the molar mass.
So you add up potassium and chlorine and oxygen, and that gets you
Oxygen times
122.551.
I got 122.548.
Well, I typed in 16 for oxygen.
Oh, I
Instead of
typed it.
15.999.
I typed it.
Well,
all
look.
those 9s.
Over there. Oh, wait, no. On the other ones, they said 16.0. Wait, let me take this one. See, look.
Oh, yeah.
This one says 16.0. So I was just like, it says different stuff. It works.
We all got this.
Wait, okay. Because from the balance equation.
Yeah, right here. And we're
No, you're going to mass and grams.
Oh. Oh.
Yeah, that's where
Okay,
where
I see.
you
I got
the
confused.
number you got is probably the correct liters of gas we want in mass. and
Yeah.
grams.
Oh, okay.
Are you missing school on Wednesday? No.
Why would I?
What time do you have to be in St. George?
I don't know.
Oh, so we have to be there at 4.
You do?
4.
You can still go to school.
Yeah, but I don't really want to.
It's only a 3-hour drive.
Yeah, but no one wants to go to school.
Yeah, why would I go to school?
I could skip seminary.
I don't know, I'll figure it
not
out.
seminary. Anything but seminary.
Well, I just don't want to miss this class twice.
Yeah, I know.
I'm missing my. Oh no, I'm only missing. We leave Thursday.
I could
now.
skip Spanish and English.
Spanish is first, so if you're gonna skip anything, don't skip Spanish.
No,
That's
because
pointless.
sleep. I need my rest.
You could, what's your second period?
English. We're just.
Can you skip that? So then you could come to AP Chem's second period. You could be like, yo, can I skip English and come second period and then leave after that?
There you go.
I'd do that.
I know so many people in second period.
Oh, that sucks. You should have taken second period.
I wanted to, but that's when orchestra is, so I can't.
Oh, yeah. I don't think I know anyone in second period. Actually, I do know a lot
Oh,
of
it's
people in
because
second
all the
period.
class critique
I probably should have taken that one too. It's fine.
It's fine. It's fine. You did it! Yay!
Oh, wait, we get a smiley face because we got it right, right?
Smiley face! I feel like I'm gonna need those this term.
I don't think I will.
I
She just,
bombed that
I have an A- right now, but I need her to put in the quiz corrections.
Wait, we did.
'Cause I have an F in the quiz category.
I fell asleep while doing the AP classroom quizzes, and
Yeah.
so I didn't do like any of them.
Oh, wow.
I waited to do all of them because honestly I forgot about them.
Yeah, I did them all on time, but I got like F's on all of them, so I had like 20 test corrections, but I did all of them. And I did the progress check. So
See,
I don't
I
think
missed so many of them that like I didn't want to correct all of them, so I just did the progress check.
But you have to correct because then
I know,
that helps you on the
How you
test.
learn.
Because like half of
That's
the quiz
why-
questions were the same as the ones on the test.
I
So I was just like,
know.
oh, I corrected this yesterday.
Yeah.
That's why I failed that one because I didn't want to correct them.
Okay, I swear there was one that I got wrong twice, and I
Oh, dang.
thought that I had picked the other one, but apparently I picked the same thing that I picked last time.
Okay, everybody. All right, any questions before we, I mean, we're going to keep practicing this, but any questions on this one? So the answer, I think I checked most, but is 3.6. If you got 3.6 grams, you can have a smiley face, you're correct. All right, here's what we're going to do to continue to practice this, and hopefully once again, like, I want you to feel really strong with this skill. Like, this is something that when you see a problem, it's almost like you're excited because you're like, oh, I know how to do this. I feel confident in doing it, so on and so forth. Okay? So here's how we're going to play. Okay?